Example 6. The uniform smooth rod shown in the figure is subjected to a force and couple moment. If the rod is subjected at A by a smooth wall and at B and C either at the top or bottom by rollers, determine the reactions at these supports, and we are assuming we are to neglect the weight of the rod. Okay, so let us do some analysis first now. It is provided in the problem that at A, it says it is a smooth wall, so therefore the support that this smooth wall provide to our rod is normal to the surface. So this is, we call that A sub x, horizontal normal, okay? And we have C here, it's either C here and C here. Okay, C, B, all normal to our uh, rod. Okay, now if you can observe that if we follow the usual coordinate axis, which is y and then x, we will be encountering multiple unknowns. But before we go to our x and y axis, now, if you can observe, we have two forces that acts, right? It's either from the bottom or from the top of, which is at point C, and the same case with our B. Now, you can either have the force kanilang diri sa ubos or diri sa ubos because either way, same lamang po yung amount of force nga gi-exert na niya. Again, we are going for equilibrium man. So whatever magnitude of our force being exerted at the bottom part of the force is the same sa kaning gi-exert nga going down nga force diri sa babaw. So therefore, if we will draw our free body diagram, it will look like following a 30-degree inclination with respect sa horizontal nato, that would be, we have going down 300 Newton, and then going up at our C, and then we have going up, this is our C, this is our B, and then horizontal, our A. Okay, and the inclination would be 30 degrees. Okay, now that's why I said that if we follow the convention XY axis, we'll be encountering multiple unknowns because if this is 30, it means that this angle here is 30 degrees as well. So if, like I said, if we follow the convention, which is this XY axis, we'll have X and Y component for our C, X and Y component for our B, right? So what we can do is we will use the concept that we know, which is by rotating or deciding the appropriate axis. And that would be, instead of having to express our C and B into its X and Y component, we will rotate our structure 30 degrees, right? 30 degrees, so that our new orientation would be, of course, I forgot to input 4,000 Newton meter at the center here. Couple follows a counterclockwise moment, which is 4,000 Newton meter. So our structure now will look like this, flat. So we have at C here going up, so we can call that now as C. Let us have that. Let me draw it here. This is our Y prime. This is our x prime. And of course, the angle would be 30 degrees. So we rotate it by 30 degrees. This is our b prime, by prime. And then at the center, we have a counterclockwise moment, which is this is 4,000 Newton meter. And our 300 now would be, instead of plainly going down, this becomes going down to the right. This is 300 Newton and by 30 degrees. 30 degrees. Okay. And our A, instead of going to the left, becomes going down to the left. A by 30 degrees. Now we provide the dimensions from 300 to C. This dimension here, this is how much? 2 meters. 2 meters. From C to B, this is 4 meters. And from B to A, this is 2 meters. Okay, and from C to our 400 Newton meter couple, is 2 meters, which is in between C and B. 2 meters. Okay, so now if you can observe, if we do moment summation, no, if we do force summation in the Y, we'll have 3 unknowns. And that is C sub Y prime, B sub Y prime, and the Y component of our A sub X. Okay, next would be, if we do force summation in the X, we can get our A sub X, right? Okay, only A and our 300 Newton now has an X component, diba? So we do force summation first, and then for our next unknown, we will do moment summation at A. Okay. We have A sub Y, A sub Y prime, and to the left, A sub X prime. Okay, we do summation of forces X is equal to 0, assuming to the right positive. So this should give us 300, and the X component would be, we have going down, then to the right. So X would be sine 30 degrees. So that's 300 sine 30 degrees minus A sub X. And our A sub X is, minus A sub X is equal to 0. So our A sub X is equal to 300 sine 30 degrees, and 300 sine 30 degrees, that's 150. And we know A sub X is the X component of our A, and the angle that our A makes with respect from the horizontal is 30 degrees. So this is A cosine 30 degrees is equal to 300 sine 30 degrees. Divide both side by 30 degrees. So let's A is equal to 300 sine 30 degrees is equal to cosine, divided by cosine 30 degrees. Then our value for A becomes 300 sine 30, that's 150. Answer divided by cosine 30 degrees. and that is 173.2050808. Okay, 173.2050808 Newton. This is our value A, the support that our smooth wall provides to our structure here, which is a smooth rod, uniform smooth rod. Now, looking back, if we do moment summation now, no, sorry. If we do a force summation in the y, we will end up with two unknowns, and that is c sub y prime and b sub y prime, right? So what we can do is we can either do moment about c, so that if we do moment about c, since we already have our value for a, so we can calculate the value for our a sub y prime, and the only unknown that will be reflected is b sub y prime. Now, pwede po na you do moment about b, so that you will end up if you do the moment summation about point b, you will be able to get the value for your c sub y. So you choose. So for this, I will do summation of moment about B is equal to 0, assuming counterclockwise positive. So what are the forces that are counterclockwise about point B? That is the y component of our 300. And yeah, that is the only force that causes counterclockwise moment about B. Now we have C sub y, which is clockwise, A sub y, which is also clockwise, and our 400 Newton meter couple, which acts counterclockwise at the middle. Okay, so it means this becomes positive, so that's 300, and the y component of 300, which is 300 cosine 30 degrees, cosine 30 degrees times its perpendicular distance from B, and that is 2 plus 4, which is 6 meters. And then we have but before we do the subtraction, since our couple, which is 400 Newton meter, acts counterclockwise at that point here, 2 meters from our B. So we add it here, plus 4,000 Newton meter. And then we do the subtractions, and that would be C sub y prime times its perpendicular distance from B, and that is 4 meters, 4, and then minus our y component of A, which is ay prime, a sub y is equal to 0. Later, I will substitute the values of our A. So since we are tasked to find C sub y, so let me pan it here. Okay, so that means I will transfer C sub y to the other side to make it positive. So this becomes positive C sub y prime times 4 is equal to 300 cosine 30 degrees times its perpendicular distance, which is 6, plus 400 minus A sub y would be 173.2050808, and the y component of our A is sine 30 degrees times sine 30 degrees. Okay, so we perform the operations. We solve the expression. This is 300 cosine 30 times 6. That is 1,558.845,727 plus 4,000 minus 173.2050808 sine 30 minus 86.6025404. Okay, so we add them. C sub y prime times 4 is equal to 1,558.845,727 plus 4,000 minus 86.6025404 is 5,472.24243,187. Divide both side by 4. So our C sub y prime is divided by 4 is equal to 1,368.08 no, sorry, 1,368.06.0797 Newton, which is the value of our C. This is our C. Since we have calculated now for the value of our C, so what we can do is we will do some force summation in the y so that we can get the value of our B sub y. Okay, we did one. Summation of forces y prime is equal to 0. Yeah, this should be forces x prime. Okay, assuming upward positive, right? Okay, so for our upward forces, that is, we have B sub y plus C sub y minus A sub y going down, prime, this is all primes, and then minus 300 and cosine 30, right? This is cosine 30, A sub y cosine 30, and BY, CY going up. Cosine 30 degrees is equal to 0. So therefore, since we are only tasked to concerned with the value of our B sub y, then this is B sub y prime is equal to A sub y is 173 point, where is it? 2050808 205 205 0808 sine 30 degrees plus 300 cosine 30 degrees minus 1,368.060797, right? That is the value of our C sub y. Now, if we do solve this one, 173.2050808 sine 30 is again 86.6025404 plus 300 cosine 30, that is 259.8076211 minus the value of our C sub y prime is 1368.060797. We solve for our B sub y. B sub y prime is equal to 86.6025404 plus 259.8076211 minus 1368.060797, and that is negative 1021.6503 6506 650636 Newton. And since we ended up with a negative value for our B sub y, what this means is that B sub y is equal to positive 1021.650636 Newton going down. This is now the value of our B sub y. Okay, you might question why one negative and why going down. Okay, if you can observe here, we have a 300 Newton force going down, and we have a counterclockwise moment here at the very center, which is 4,000 Newton meter. So just visualize it that this single rod here is being rotated, it's being turned counterclockwise. So in order for this smooth bar to be in equilibrium, meaning although there is a tendency that this structure wants to be rotated counterclockwise, it will not move counterclockwise because it has a force going up exerted at C, and to maintain that good, we have na po tayong gibira na force at B. Right? So that is why from our initial assumption wherein B sub y is going up, no, the support that our point B exerts to our structure is going down. Again, in order for our smooth bar to be in equilibrium under this kind of situation. So that is 1368 for C sub y and 1021.650636 Newton going down for our B sub y.